So again, we have another scenario. This time, okay, we have buffers, okay, the same buffer, but with different pH values. You can actually use these two buffer solutions to create another buffer with the same concentration of our components and the same this with your target pH. Okay, so in this problem, later your friend told you that there are phosphate buffers in the stock room. So you have phosphate buffer with pH 6.7 and pH 7.5. If you were to prepare your 1 liter phosphate buffer of pH 7.1 using these solutions, how will you do it? So in this case, we're not using the Henderson-Hasselbalch equation because we already have buffers. We use the HH equation to prepare a buffer from the components. In this type of problem, we are preparing a buffer of different pH from two buffers. So what we use is the modified dilution formula. You will find your modified dilution formula in the Canvas module. I will write it down here. So we have molarity final times volume final equals the M1V1 for the first component, or sorry, the first buffer solution, plus the MV, so M2V2 for the second buffer solution. You have to remember that the molarity that we are talking about here is the molarity of our hydrogen ions or hydronium ions. Okay? So since we are given the pH values, you can get your concentration of hydrogen ions from the given pH. So how do we use the modified dilution formula to prepare our 1 liter phosphate buffer of pH 7.1? So our target pH is 7.1. So the molarity of our hydrogen ions is the anti-logarithm of the negative of the pH. So that's 10 raised to negative 7.1. And we have our desired volume, which is 1 liter or 1000 ml. Next, for our first component, which is the first buffer solution, which is the one with pH 6.7. So the concentration of our pH 6.7 buffer is 10 raised to negative 6.7. I mean the concentration of hydrogen ions. Then we represent the volume for this buffer solution with 1000 ml minus X plus the concentration of hydrogen ions in the second buffer solution is 10 raised to negative 7.5, and we represent the volume of the second buffer as X. So we have here 1000 minus X. That's because we know that the total volume of our final buffer is 1000 ml or 1 liter. Now we can just solve for X. So I leave the solution to you. You practice on your own. So for the X, you should get a value of 715.25 ml. This is for the pH 7.5 buffer. And it follows, so we just subtract this from 1000 ml. It follows that you need 284.75 ml of the pH 6.7 buffer. So you just mix the two again, okay, again, check the pH of the final solution. If it's equal to your desired pH, then that's okay. If it's not equal, we adjust using hydrochloric acid or sodium hydroxide.